friends.
Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Jonathan Ellis, founder of DataStax and with founding project work on Apache Cassandra, developer of JVector, and many very interesting open source projects. Thank you for joining us, Jonathan.
Thanks, Luca. It's great to be here.
Would you like to give us a quick introduction about yourself?
Well, I guess maybe one of the unusual things about me is that I started DataStax as a developer. I led our engineering team building Apache Cassandra for several years. Then I moved into the management side and I worked as VP of product for a couple years. And that basically just about killed me. So I took a year off, wrote some generative art while I was recovering, and then came back to work as an engineer again. So what really makes me happy is writing code and creating something that didn't exist before. But along the way, I've touched a lot of the other things that go into building a 600-person company.
Good, yeah. Well, let's start from the project first. What is Apache Cassandra and what is generally used for?
Apache Cassandra is a distributed database, and so companies like Apple and Netflix and Spotify and almost all of the Fortune 1000 use Cassandra for its reliability and its performance at scale.
Okay, so it's NoSQL type of database, correct?
That's right.
Well, yeah, there's a lot of use cases for that kind of. And you also work on JVector, correct?
Yes. So this past year, I've been adding vector search capabilities to Cassandra, and the approach that we took was to separate out the approximate nearest neighbor index into a separate Apache licensed open source project called JVector. And so that's used in both Apache Cassandra 5.0 as well as DataStax's hosted Cassandra service called Astra.
Vector databases are very all the rage right now for AI reasons. Everybody is using some kind of vector engine. So, what are the advantages of JVector, just so people can go check it out?
Yeah. Should we talk about why vector engines are useful in generative AI, or is that
well? Yeah, I think so. Yeah, that's a good starting point. That's a very good starting point.
Yeah. So the thing is, when you're using a generative AI large language model like GPT or Gemini or the open source Llama models, they all have one thing in common, which is that they're trained on a vast library of human knowledge, but they don't remember all of it precisely. And which makes sense if you think about you're basically trying to compress the entire sum of human knowledge into one of these models. And one of the founders of OpenAI, Andrei Karpathy, I hope I'm pronouncing his name correctly, likes to say that the models dream, as opposed to
nice.
normal computer calculations that are doing something very precise. The language models create dreams. And the dreams can be more or less anchored in reality. And the common term in the industry when they're not anchored in reality is to say they're hallucinating. And so one of the techniques you can do to make them hallucinate less, and almost entirely eliminate it, in fact, is to give them background knowledge explicitly as part of your question to them. And so, for instance, I did an experiment where I asked ChatGPT Pro to tell me about Apache Cassandra's unified compaction strategy. And it gave me some very, very high level, very generic information about it. So it was something that it recognized, but it wasn't very confident and didn't know very many details. But when I gave it a page of documentation about unified compaction and said, now tell me about it, it gave me much more accurate, much more useful answers. And so the reason why vector databases are so interesting right now is that it provides a way for you to index your business knowledge and create a knowledge base that you can do a semantic search for and say, here's what I'm going to ask the AI about. And the vector database will come back and say, here are the most relevant documents to your question that you can then give the AI as context to its answer.
And I will add that with the advent of large context models, like Google's newest Gemini has a 1 million context window, you still need to do a what's called retrieval augmented generation. So search for relevant parts of documents and put them in the prompt instead of just feeding the entire thing to the engine. Well, cost aside, even if it were free, too large of a context doesn't give you good answers. We've been testing
Yes,
that for a while.
there's two challenges, even with a model like Gemini 1.5 Pro, which is the million context version of Gemini that isn't, well, as of when we're talking, it's not generally available. It's available to a few testers, but possibly by the time this is released, that will be live. I look forward to playing with it. But even with that million context window, there's two challenges. One, as you mentioned, there is an accuracy challenge. So the Gemini paper that they released with it gives an example of saying, hey, when we give it this one, they call it the needle in the haystack. We give it one needle in this very large haystack to find. It's actually very good at finding one needle. But then when you ask it to find 10 needles, its performance deteriorates significantly. So there is a performance issue with the model being able to pay attention to the entire context simultaneously. The other issue is a different kind of performance, which is how fast does it respond? And so when the way a language model generates its response is if I give it 100 tokens of input, then the first token of its answer is processing 100 tokens. The second token of its answer is processing 101, the input plus the first token of the answer. The next token is 102. So it's not like here's the input and then it calculates and gives you an output, but rather it gives you part of the output, then it gives you the next part, then it gives you the next part. Each time it's processing that entire context containing what you gave it and what its answer is so far. And that's how it kind of remembers where it is in creating your answer. And so the longer that context that you give it is, the longer it takes to get an answer out. And so with million context Gemini 1.5, what I'm seeing is people are reporting query times of in minutes rather than in seconds, which that's absolutely like a useful tool to have at your disposal. I would much rather have the option to do a million token context when I need it than not have the option. But for the vast majority of use cases, you're going to want something faster, and you're going to want to help the model find the most relevant information rather than dumping everything into it.
Even so, SingWire has been doing a lot of work on our AI attendant, and even with much smaller context, like we run classic GPT with the 30K context, and we've seen people, we've recommended people break up large context, because it's another problem we've seen is that somehow the middle part of the context, if it's too large, gets almost ignored. As you probably certainly know how LM attention works. The middle part, it probably loses attention somewhere in the middle. And we've even seen cases where it was hallucinating badly, either giving wrong responses, or just today, I just saw an instance in the logs where we've seen GPT throw out random words. Probably the first time we've seen it.
Wow.
A huge context it's a very huge and bureaucratic context for a Department of Motor Vehicles. They're trying to do information about what documents you need to bring when you go get your license or whatever, and it's 70 pages or something like that. And we got a response that it's literally random words after about halfway. It's super interesting. So there's so much we don't even know, probably.
That's pretty cool. If only If only there were a prize for breaking GPT, like that would be cool.
Yeah, there's plenty. I mean, GPT or any other engine. I've seen something similar with Mixtral, which in the open source space though is very very interesting. So that's I think Mixtral is going to be a key part of the first open source production solutions we'll see around there. It's the first engine. It's really good, to be honest.
Yes. Yeah. So my colleague Jake Luciani has created another open source project called JLlama, which
Hmm.
allows you to run these different open source models from Java using SIMD acceleration in the latest JDKs. And so JLlama supports Llama 2, but it also supports Mixtral. It supports some of the smaller models. Uh, as we're talking, Google just announced Gemma or Gemma,
Yeah.
smaller models that Google is open sourcing, and Jake's adding support for those as well. So yeah, Jake's a fan of Mixtral as well.
Yeah, we've seen a lot of again, Mixtral is the first engine we've been able. So we have an extensive set of tests we run internally every time we change something or we want to test something. Mixtral is the first engine we've seen actually score somewhere where it's reasonable to look at it again in the space. So it's pretty exciting. Hardware needed to run it, notwithstanding, etc. But something I want to go back to at the start. You mentioned DataStax is 600 people company.
Yeah, give or take a handful, but yeah, that's about the size.
Well, first of all, congratulations.
Thank you.
And second, one of the topics we often talk about in the program is how people can grow companies out of open source projects. So I guess I should ask you how you did it, since it's definitely a
Yeah,
success story.
and that's actually the order in which that it happened. Is that I was working on Cassandra before I started DataStax, and when I did start the company, there were a bunch of things that I wanted to preserve from that open source environment. In particular, the ability to hire great people, and no matter where they are in the world. Uh, and so the background to how I got started working in Cassandra is that I didn't create Cassandra, so that was open sourced by a team at Facebook. So they open sourced
I
it in the
remember that. Yeah.
summer of 2008, and then contributed it to the Apache Foundation a few months later. And so I came in as the first non-Facebook committer on Cassandra, and one of the things that uh, really helped bootstrap Cassandra from something that was only used at Facebook to something that's used all over the world is that open source success story of it is a bazaar, to use the
Hmm.
20-year-old term of Eric Raymond. It's not necessarily a cathedral, but it's a bazaar where lots of people who want to make Cassandra better are improving it. So one of my roles early on was just kind of a cat herder, where there were a couple people working with me at Rackspace on Cassandra, but the other people who were contributing to Cassandra from Netflix, from Spotify, from Twitter early on, those they didn't report to me. I couldn't tell them what to do, but I could suggest and say, hey, looks like this is going to be an important problem to tackle in the next release. What do you think about what approaches do you think would work there? So
Yeah.
and we're doing this across multiple time zones, right?
Mm.
The Spotify guys are in Scandinavia. I'm in Texas. The Twitter guys are in San Francisco, and so all of this has to be done asynchronously. And I became convinced that this is a better way to build software and to coordinate a team of people working on it. Uh, so when I started DataStax, I've never worked in a room with my team of engineers. It's always
Mm.
been that kind of open source inspired model of we've got Jake in New York, and we've got Sylvain in France, and that's how it's always been. And I do think it's a better way to build a company and to build code.
So how well, that's first of all, congratulations. Second, SignalWire tries to be built on the same principle. So we also have a distributed team. We don't really have an office. Everybody is in a different time zone, and it's been a challenge. So I'm curious, what do you think have been the success factors in being able to scale to such a size with distributed teams?
Yeah. So first of all, I will for the sake of honesty, I will clarify that we do have a corporate headquarters in California.
Well, with
Uh,
600
it
people, you need one. I mean, it is.
Yes, yes, and so our finance team, our HR team, are they're not entirely co-located there, but they're mostly
Mhm.
co-located there. But the engineering team is effectively 100% distributed. We do have a couple people working out of the Santa Clara office, but they're working with people all over the world, just like me. And so when they have a team meeting, they're still not going in a room and locking the door and doing it all face to face. They're doing it on Zoom, like the rest of the company. So yeah, on the engineering side, it's basically 100% distributed.
Nice. How do you communicate?
So I have a very, very large preference for asynchronous communication,
Mm.
and so that's driven partly by it's more efficient, and partly by it works better when you have those people in multiple time zones. So if I say, hey everyone, we're going to do a stand up meeting every day at, let's say, 11 a.m. Texas time, which is 9 a.m. for the people in California, then that means that it's what is it? It's like 3 a.m. for our engineer in New Zealand, something like that,
Yes.
and it's 6 p.m. for the engineers in Central European time. So it's inconvenient, first of all, and it does kind of push you in the direction of saying, other things being equal, I want people in the American time zones because that's just more
Mhm.
convenient. And so it dilutes your effectiveness at building that worldwide pool of talent. But even if I did have some imaginary team that were all in Texas with me, I would not want to interrupt everyone and say, okay, everyone drop what you're doing at this time every day and get on a call with me and tell me what you're doing. So what we do instead on the teams that I lead is we have a Slack channel, and every
Mhm.
day whenever you start work, which for me is around 8 a.m. Central Time, and for Michael, it's around 9 a.m. Eastern time. Well, actually, that's the same time. But whenever you're starting work, you just drop a couple lines into Slack and say, "Here's what I'm planning to work on today." It's literally just like a couple bullet points. And then as the day goes on, if you discover something interesting, or maybe you decide, you realize that, hey, this other thing is a higher priority, then you can just add that into that Slack thread that you have from your original one, to say, like, here's what I learned, or here's the direction I'm going in now. And then as the team lead, or actually not just me as the team lead, but really anyone on the team can say, oh, Joel, that's an interesting thing that you posted. I had some thoughts about that the other day. Is that on your radar? And
Mhm.
so obviously this works best with smaller teams, which is the best way to organize software development anyway. But you can have the entire team aware of what everyone else is doing in a non-invasive fashion. So nobody's having to come out of their flow of productivity to engage with that, but rather whenever I get to a good stopping point, I can go over and check Slack and engage with that. And I have very strong opinions about the right way to use Slack, by the way, which is basically turn off all the notifications. Because if you're trying to be productive, if you're trying to solve a difficult problem, and then Slack's going bing bing bing, that's it's just impossible to concentrate. So turn off all the notifications, engage with Slack when it works for you, rather than when it works for Slack. And then of course you do need to have that, and that means that if somebody does need me like right away, then they can text me, right? Then there's other channels, because Slack is when I get to it, not I'm going to be on this right away.
That's an interesting way to put it. I think we've used Slack too, as many teams do. One thing that has worked very well for my team, and I'm trying to propagate around the company, is do not use direct messaging unless something is either urgent or is it's actually not work related. Like it's okay. It's actually okay to say, "Hey, did you watch the game last night?" I'm fine with that. Just don't do the work-related discussions in PMs unless it's.
That's a really good point, and that's absolutely correct. If it's something work-related, like you say, it should be in a public channel or a team-related channel, so that it's visible to other people who it may be relevant to.
Team-related channels are good, of course, for containing noise more than anything. Like, of course, if you're working with a back-end team, the people working on the UI for the website probably don't care about your Kafka having gained some performance or whatever. But it's the different thing. I think the PMs really limit the ability. First of all, they're very distracting, because a message in a channel, even if it addresses you, it's still in a channel, so it's sort of sitting there. Well, if you get a message from someone, you feel compelled to go and answer, because there's they're talking to you. It's kind of like someone walking to your desk and saying hello. So it is. It's really a different thing. So PMs are only good for sometimes private conversations if you need to have them, but otherwise for the work stuff, it's never useful. Never been useful once.
And I want to touch on another thing you mentioned with the team channels, is that the team channels should be for the team. It shouldn't be for the team and anyone who's interested in what the team is working on. So I'll often create a dash collab channel. So we have a vector search dash collab, which is 120 people. It's like everyone who's interested in vector search. And you can ask questions. You can say, hey, is this a bug? You can say, oh, customer X is working on problem Y. But for the team that's actually building vector search, I want that to be small and focused. And besides the issue of the signal and the noise, that helps have a kind of esprit de corps of, hey, we're working on this together, and we can be blunt with each other inside this team channel, and people can say, Jonathan, that's a dumb idea, and here's why. And it's inside the team. Like, it's all good. Like, the team can tell me, hey, this is a dumb idea inside the team channel. It hurts my feelings a little more if there's an audience of 120 people, where you're telling me that it's a dumb idea. And maybe that's just a Jonathan problem, but I kind of think that it's a human nature thing, that it's easier to process that kind of feedback in kind of a trusted environment.
I absolutely agree, to the point where I think teams should have a channel that does not include the direct report. So say you're under the CTO, you're a team working on something, you're under CTO, you should be able to have a channel where it's only the people who are actually working in the department. The CTO is not in there. Not because we want to say bad things about them. That's never happened. That's something for HR. But that for exactly the same reason. It's okay to have a dumb idea once in a while. And it should be played out safely. Like, Luca, I don't think this works. Literally, this is just bad. You just wasted 4 hours spiking out something that's not useful.
Right.
It happens.
It happens.
And it doesn't put you in a bad position, because usually your CTO or whoever is going to be perfectly fine with it and know exactly why that happened if they trust you. Otherwise, they shouldn't have hired you. but still, it's something that you cannot really openly discuss. So you end up trying to find a reason why you spent those 4 hours. More time instead of just saying, well, you know what, this was a dumb idea. Rewriting this thing in Lua was a bad idea. Let's use JavaScript. And that's it. Okay, I'm good. Okay, you're right. It's bad. And it is there's a few nuances there that are very, very important, whether or not whatever the channel is. So
Right.
not the same thing as not including so the manager of the team is part of the team, but the reports, like the seat person you're referring to, maybe don't include them in every conversation. They don't even need to figure that out. Sausage making is reserved to the people who are actually making it. I think I agree with that. I definitely do. What about email? What do you think about email? These days, it feels like email is for sales only.
That's a good point. I think I've moved away from emphasizing email over time. And part of the reason why I started out doing more with email is because that's an Apache Foundation thing. Like the ASF says, if it's not on the mailing list, then it's not part of the record, and so do as much on the mailing list as possible. But email is kind of a bad format for interactively uh, building a design together. So I gravitate a lot more towards Google Docs now for longer form write-ups because of the commenting feature. Like that's just super useful that I can sketch out a proposal and throw that out to the team, and then they can all come in and say, okay, here's what we like, here's what we don't like, and then it's kind of the same thing that you can do in email, but it's just a much better format. The workflow is much smoother doing it that way. So yeah, what do I use email for? I mostly use email when I'm interacting with executives at DataStax who are not very good at Slack. I'll put that. That's how I'll describe it. So if I want to make sure that our VP of product sees something, then I'll send him an email because that tends to be higher priority than Slack for him.
That's it. Yeah, I think on our side, email is really much more used for sales, or of course, internal communications, large internal communications. Like if you need to tell the whole company an official message, then it comes through email. I think that actually keeps it like it's more of the official channel. Like it's where the important thing. If you get an email, it's usually important. We're all being very good and not signing up for mailing lists unless they're relevant. So when you get an email, it's important. I think that's a good thing. The other thing I really despise about email, and that's about the client, it's not even about the clients, how it works, is the reply chain when you're working with a company or two that's involved and they all have large signatures. So after 50 email exchanges, each email message is 2 megabytes of HTML and a line saying, okay, I agree with that, let's proceed. And the rest is 2 megs of GIFs and signatures and heads of this and lead of that. And it's just, I don't know why there has never been, there might be even a product in there. Like if one day you'll sit down and figure out email that doesn't have all the signatures in it.
Maybe you need to write an AI agent that takes the signatures out.
Yeah, there's something in there. Right? We might just accidentally stumbled into our next open source project. Who knows? The signature remover. It might work out as a library. Who knows? Well, I mean, I really appreciate you joining us today, and I think there's a lot we should talk about more, but especially about the vector database and in general the work you're doing with that. And so go check out DataStax website, especially the AstraDB vector product, which I've been taking a quick look on the side while we chatted, and I'm going to sign up right after I hang up because I really, really want to play with it a little bit. And well, again, congratulations. And well, growing a company to 600 people on an open source project is really, really impressive. And distributed company, double impressive. So, well, I think that's, I just wanted to say that's just great. And
thank you
we
so
will
much.
strive to compare to. we're getting. So a question I hadn't asked you: when did you start the company?
Spring of 2010. So coming up on
Oh.
14 years.
Well, that's nice growth. I mean, it is still very good. It's a big site. Well, again, Jonathan, thank you very much for joining us today. It was a great chat, and hopefully, maybe we can do another session if you'd like, just on the vector database. Maybe doing some examples, a tutorial of sorts, something like that. Because I know we'll get messages from people saying, "Hey, why did you do that?" So I'll prevent that by just asking.
I'd be delighted.
Perfect. So for the audience, look forward to the next episode where we'll go about looking at JVector and Astra and the vector database. For now, thank you, Jonathan Ellis, founder of DataStax, for joining us today.
Thanks again for having me.
And for the rest of the people, I'll see you next week. Goodbye.